in order to see how to connect the DC power source, which is powered by AC and then converted to DC, we just gotta look at the batteries are placed inside of the August door lock, and we can see that there's positive on both sides here and negative on both these sides. But in actuality, they're in series. It's a 6-volt system because each of the batteries is just 3 volts and they're wired in series. So if we were to test this and I have myself, we would see that this spring and on the negative side on the left and this positive are actually tied together, whereas this negative on this side and this positive on this side are separate. So if we connect a positive part of a power supply, DC power supply that's 6 volts or more, but less than 6.5 volts, we would get power to the August working properly. Now, the problem with hooking up a power supply directly to these two leads is that this cover is really tight fitting, and so you're gonna run out of places where to run the wires without making everything look kind of odd. But we can see that as the door lock rotates, the plastic piece here doesn't really rotate. Only this outside piece does. And likewise in the back, if we look at this plate, the plate and the plastic do not rotate. Only the metal piece here rotates in the spindle in between to open the door lock. And because of this, we may be able to open this up, look in the inside, and find ways to solder wires from these locations all the way through to the back and make those wires thin enough so that they can maybe eke out on the sides here, allowing you to run them the way you want on the door to the power supply. So let's begin by disassembling this lock and seeing where we might be able to run those wires. There's only 3 screws that you really have to undo, and the 2 larger screws on each side of the locking wings, that's what we'll call them. Oops, didn't quite get that. And 1 smaller screw, quite a smaller screwdriver here that's quite deep. Now, having had opened this before, I'll say that you have to be a little careful, as this bracket cover has a battery and a wire that connects to circuitry, and we'll see that in a second as I pull this out. So you can see that there is this wire that connects over, so you don't want to damage that. You want to be very cautious. And there's this white ring that you can see around the periphery, and that white ring operates in a very specific way in relationship to this outside bracket. We can see that when we put this back, the cutouts are aligned so that it will fit. So we want to kind of pay attention to where the white ring and the black back piece kind of mesh together to fit. Otherwise, as we turn the lock body, we're going to lose alignment, and so a bear to kind of figure it out. But the large tell here is that the big scoop that's cut out aligns to the motor, and the long flat piece on the bottom aligns to this metal arm. And if we start there and see that these double scoops on each side align to essentially these thread posts and this open area where this long protrusion for the smaller, thinner screw goes, then we can have a good reference to how things should line up in order to get it back and make it smooth. So just pay attention to those things and we'll be fine. Just want to let you know up front. So in terms of wiring the power, I'm going to use just, because I'm not really caring about the cosmetics of the wiring right now, a thin but heavy enough gauge, and I think this case it's a 28 gauge. It might even be a 32 gauge. As this is a very low current, low power scenario, we can use a similar gauge to what they're using for the motor for the lock, and I think this is fine. So for me, if I can move this wire in a way where I can get to those 2 power supply points, or find them here, in case I can find them on this side of the board, solder the positive and negative, then potentially drill a hole in this plastic piece and have that wire come out of that piece and snick through, let's say maybe where these wings are. Now we have a place where we can run the wire on either side and still allow the lock body to move independently while not being obtrusive of the cover. So let's see if we can find a place that will allow us to do that, and then I'll also then drill a hole in the plastic cover here to find a place where we can run the wire to the outside. So by reassembling the back cover without the screws and just holding them in place and tipping this up carefully, we can see that the front piece, while holding the back together, slides all the way out. Again, be mindful of that wire that's there. And we can see that there is room around some of these edges, including this area right here where the screw would come through from the lock post on the back of the black plate. We couldn't find areas like here and down here where we can run wires and solder them, or find the place where they actually come out of the motherboard. But it's trickier, and I think for the sake of safety, it'd be better for us to solder directly to the places that we need to. So this point here, and then run the wires through the holes and then back out the back. So I think that's where I'm going to start. I'm going to see if there's a way for me to disconnect the cable from the back of the plate to the circuit board, because that might make it way easier for us to work here. Not positive if that's a pullout or not, so let me see if I can disconnect this. You'll lose your Wi-Fi settings and such by doing it this way, so be cautious. I don't want anyone to be frustrated with having to set it up all over again, but that's kind of the price you pay if you decide to undo this. So let me see if I can simply pull this out. There it is. So this is a connector, and if you look carefully, let me see if I can focus on that. Yeah, so this is a connector that pushes in, and we'll note the polarity. So the positives on the top here, and the negatives on the bottom, or negatives closest to where the wires are. That just plugs in. So once you've unplugged that little connector, this piece can be set aside, and we have full access to the inside of the mechanism. So that makes it way easier for us to operate. So let's start there. And what I'm going to do then is I'm going to run the ends of the wire split to the two proper inputs, this one and this one, that allows us to run 6 volts to the entire circuit. So what I'll do is I'll separate this wire. And because this is positive and this is negative, I'll just strip this wire a bit. Because they're pulled apart, it's much easier to actually find a way to get the wires inside of this little cavity. So let's first start with where we would actually have the wire come out of the circuit board. And I think that the best place I can see right now is right next to that black screw hole. So if we look at this and we assemble them as it would be normally, we can see that there is a little bit of room, even if we wedge it to the side of each of the posts there like this. So because there's enough room and I know it can fit, I'm just going to work with a pretense that that is going to work after I solder it. And I know that's not the best thing to do without testing, but I have high confidence. Let's just proceed with that right now, and if it doesn't work, we'll fix it as we go. So the first thing I'm going to try to do is fish the wire around the motor. We know the motor is high enough and has enough room clearance with the back plate to have a cavity around it, which is where we'll run our wire. And then, in order to make sure that the form factor is all working properly, I'll wrap it around this post as well. And the entry is here, so we can see it popping through. And as I bring that through, maybe give it a little more room. We have this wire in place, and we can work on this wire now, which is the negative wire. And this one will do the same thing. I think I need more length here. Well, we'll fish it internally in order not to be obtrusive. Go all the way down the body of the lock here. Oh, sorry, the battery cover. And we can see it come through on this side. And then we'll grab it. Just because it makes it easier to manipulate. And then from here, we'll go upwards into the battery cover body. There we go. So there we go. So now we have our wire in the proper place. So between the negative for this pole and the positive for this pole, we need to wrap the wires around and drop a little bit of solder on each of them to hold them into place. So just to show how I came up with the idea that the two proper contacts were these two and not anything else in any other combination, is my multimeter has a continuity testing function where if you touch, it makes a sound, a beep. So when we touch this coil, which is the negative on the left side, and the positive on the right side, notice that there's a connection. That means there's an immediate and direct connection with almost no resistance between them, meaning they're connected. And when I do the same thing with these two, or any other combination, it doesn't actually give that same continuity. So in that way, we know that these two poles are connected and form the bridging circuit. So it will go positive to negative, and since they're both 3 volts together, they form a 6 volt power supply. And so the power supply, and I'll list it in the description below, I'll use is a 6 volt power supply. In actuality, it is really giving out 6.4 volts as tested. Under load, it'll probably drop slightly. It should be quite enough. I've tested it prior to disassembly, just from a mock-up and a roughing perspective. So I do know it works, but that's how I found out which 2 poles are the live ones. Now mechanically, I have the wires touching solidly to each of the springs, and I'm just going to spread a bunch of flux along those connection points before I solder, just so we can have a nice clean solder joint, make sure there's no corrosion, and to make the solder flow a little bit easier. So I'll do that on both sides here. Then in order for me to solder this properly, I've set my my welder to a decent temperature that can handle this small gauge wire without overheating it. So I'll bring that in, I'll touch the metal together. Okay, so in order for these wires not to rub along the rotating cylinder in this area or along the periphery, we want to be careful to tuck this in a way that when we put the back plate back on, it's not really pressing or pressuring or wedging the new wires into any of the moving pieces. And because the movement happens from here over, I drilled my hole through the cover on this side because the swing arm doesn't really move past this point. So based on this, if all goes well, and we can just test fit it right now, this long post should be able to fit next to the black wire, and we should be able to tuck all these wires up into this corner here, free from any binding in between and free from the outside edge. We'll have to put the power supply wire for the backup battery back in, but for now, let's just try to test fit it. Again, let's pay attention to the orientation of the plastic ring, because as I said, it's 2 humps, the bottom humps here for each of the screws, the motor has the big cutout, and we should be able to slowly and carefully align this to those holes and see if we can get it around the wire, the black wire, and see if we can. There we go. So it has test fitted, and let's see if it moves. So it moves quite well. No interference felt. So at this point, I'm fairly confident that the wire can move to this side if I want, or through to this side if I want, because of this nice little cutout in between and the thinness of this wire. So don't go too thick on the wires you're using. But let's take this back apart for a second. Careful for that white buffering ring. Let's reattach the battery and then reassemble with all the screws, and then do a test to see if we can get it to run on DC power on the bench. So let's grab this guy. There's 2 little pins. There we go. Yep. Let's reform. There we go. So let's put the anchor screws back in underneath the wings. Okay, so all the screws are in now, and it's tightened. You can see that it moves quite freely, smoothly, and I think that we're ready to go. On this end, we can undo these soldered ends if we wish to, and now we have a wired August Home Wi-Fi lock. Now, in order to test this a little bit, let's strip the other end, and let's run the power supply to this lock. So this is a very typical Chinese power supply. It has a rating of DC 6 volts at about 5 amps max. We don't need nearly that much amperage or current, but it operates on 100 to 265 volts AC, so it can be a variety of input sources from the AC side. It's regulated, and the middle of the connector is positive, the outside is negative, very prototypically, and they even nicely included adapter. So this adapter plugs in, and this end is where you put your wires. So theoretically, since we know which polarity by color, since I've used colored wiring, we should be able to attach this to the connector, and when we plug it together, since it's powered on right now, it should power the lock. That's kind of handy. So we'll do the positive first. Let's make sure we can get them there. There we go. And the positive is handily marked. I'm not sure if you can see this on the focus, but it's marked positive and negative. So, and remember that because it came with the power supply, and the power supply is standard, meaning that the center tip is positive and the outside shield is negative, this works perfectly fine for that purpose. There we go. Now they're well connected. So if this works, we should be able to power this immediately. You'll see the light turn on when I plug this in. And it does. There you go. So I think we're good to go. Now I just need to mount this, run the wires, and test it. And I'll do that next. Okay, as you can see, the lock has no batteries, but has the wire, which successfully was routed to the right side, and can exit the back of the mounting just where one of the wings are, as I thought. So don't use too thick of a wire, not too thin either, because it does need to have proper ratings. And then let's test the unlock feature. Yep, that worked fine, and has a lot of grunt to it because there's extra amperage, and the batteries will always register as being completely full. So with that, I think just have to run the wire whichever way works for me and my door, but I call that great success. Thanks all.